Welcome to a new video series on combinatorics. So this video is just going to introduce the series. What is this series about? Of course, combinatorics. What is combinatorics? Combinatorics is the study of combinations, especially enumerating ways of combining sets. You know, some of the familiar ideas that you may have encountered that are sort of regarded as combinatorial in other classes would be sort of like counting formulas, right? Fundamental theorem of counting, you know, a whole idea of permutations, combinations, and so on, right? Those all fall under the sort of like, those are core combinatorics topics. As far as the details of exactly what in this field I will want to get into, I haven't fully decided. I'll sort of hit the things I know that I want to get into, and then once that's done, I'll sort of look around at other things that I could get into from there and make decisions as I go. Definitely some of the core topics would be counting formulae, recurrence relations, graphs, generating functions, probabilistic methods. I'm pretty sure I want to discuss Polya counting and Burnside's lemma. Ramsey theory is very popular in this topic, but that seems really hard and, in my personal opinion, not interesting enough to really warrant the effort. That's totally my opinion, but so I doubt I'll get into Ramsey theory. I'll definitely talk about graph theory, and certainly, right, matching, coloring, and connectivity are some core topics. I'll definitely want to talk about those. I don't know what else. Prerequisites for these videos, right? I'm going to assume that the viewer has already taken a course in undergraduate discrete mathematics. So you should know about graphs at least a little, hopefully more than a little. Should know a little bit about probability, sets, some exposure already to counting, sigma notation, just the stuff you get in discrete mathematics. The next prerequisite is a little bit more of a squishy prerequisite, but this is a fairly advanced mathematical topic, and therefore we're going to be doing rigorous proofs, and so you should have plenty of comfort with rigorous proofs. You know, ideally you would have already taken a course in abstract algebra, especially, you know, when you get to things like Polya counting and Burnside's lemma. Those, right, may be quite hard to understand if you don't have the background in sort of abstract algebra, group theory kind of stuff. So anyway, comfort with proofs is necessary. Some exposure to basic probabilistic sort of reasoning and manipulations. This one is the least of the prerequisites, in the sense that, like, if you hadn't had, like, this could just be the probability that you learned in a decent statistics, right, intra-statistics course. Like, if you hadn't taken any course that previously talked about probability, you might be able to kind of figure it out, just kind of put in some extra effort that when it comes up, you kind of look into the relevant parts of probability. But ideally, you already know at least, more than the first few things about probability. That would just make this easier on you. So I would list those as the prerequisites. Finally, I want to give an acknowledgement for how I've been developing these videos. These videos are developed based on the material in the textbook Combinatorial Mathematics by West. In fact, these videos are very much designed to be kind of a companion to the text, right? So, so you see the videos, hopefully my explanation makes some amount of sense, and you can also cross-reference it with the textbook, have two different people explaining it in two different ways in two different mediums, and hopefully that just makes it so much easier to understand what's going on. So I encourage the viewer to get this book and sort of follow the videos parallel to the relevant sections in the textbook.